Hi everyone, and welcome back to another topic video. This one will be on writing rate laws and the calculations that are associated with rate laws. And I have an example chosen from your workbook. This is question number 5. It's on page 27. If you want to follow along with that, you're certainly welcome to. Or you can just keep watching and use this as your guide to answering any of the questions that you have for rate law calculations. All right, so let's get started. So here is our workbook question, question 5, page 27. We're given some experimental data, as you can see from the question, experiment 1, 2, 3, and we're given some initial concentrations here of ammonium and also nitrite and a rate of consumption done in 3 different experiments. We're also asked a bunch of questions here. What's the rate constant? What is the rate law? What is the order? And then calculating of rate for certain reactants or products. All right, so when we start a question like this, if we look at question A, it tells us the reaction is first order. With respect to each reactant, what is the rate constant? I don't particularly like starting with that particular question. I always write my rate law first, so I'm going to skip down to part B here, and I'm going to write my rate law first. Now, when you're writing a rate law, they're always written the same way. I'm trying to get this pen to work here now. So it's always written the same way. A rate law looks exactly the same every time you will write it. Rate equals K, which is the rate constant. It's a lowercase k, even though mine doesn't always look like a lowercase k, multiplied by the concentration of your reactants. So it's ammonium first and nitrite for the second one. I will go back to question A because I'm looking for a piece of information given in that particular question, and it tells me the reaction is first order for each reactant, which means my exponent here for ammonium is a 1, and for nitrite it's also 1. It's first order for both. Now, you don't have to write the 1, obviously. You can leave it blank there, and it's just assumed if you don't write it, it's a 1. But if you want to write it in, you can write that in as well. I will go back to question A now and want to find the rate constant. So I will use my rate law, which I just wrote in question B. I'll use that as a formula, and I will calculate the rate constant, K. So rate equals K times ammonium times nitrite. I can rearrange this to find my value of K. So K would equal the rate divided by the concentration of ammonium multiplied by the concentration of the nitrite. Now, you can use any of the data you like from experiment 1, 2, or 3. Doesn't matter which one you choose as long as you're using the same experiment for all 3 values. So don't use ammonium from experiment 1 and nitrite from experiment 2 and the rate from experiment 3. Make sure you're using the same for each value. So I'm not going to show that here on the page just because it's a little bit cramped. It's a little bit small there, but I am using experiment 1 data. So my rate was 7.2 times 10 minus 6, and I'm dividing it by the ammonium concentration, 0.24, and the nitrite concentration, which was 0.1, and I get a rate constant of 3.0 times 10 minus 4, and the unit of this is now moles per liter minus 1. You could say per second, or you could do moles per liter minus 1, S minus 1. I think that might be a little bit easier. Actually, let's just leave it at that, and I'll take this one away. So So moles per liter minus 1, S minus 1. That's my unit for my K value, my constant. Skip back down now to question C. What is the overall order? The overall order is given from the exponents. All right, so 2 is the overall order, and I got that by adding together the 1 and the 1, the 2 exponents from my rate law. So first and first makes us second order overall. What is the rate when the concentration of ammonium is 0.39 and nitrite is 0.052? So again, I'm going to use my rate law as a formula. Rate equals K times, ammonium multiplied by nitrite. Right, and I'm going to sub in my values for this. So I'll use my K from above, from part A. There's my K. And ammonium is given in my question. So let's see, what do we have here? So 3 times 10 minus 4. Minus 4 divided, or multiplied, by 0.39, multiplied by 0.052. And I get 6.1. I am going to round this to my 2 sig figs, just to match my values given in the question. 6.1 times 10 minus 6, and this is a rate. What is the reaction rate? The unit of rate is moles per liter per second. The rate of consumption of NO2 in experiment 1, I'm going to come back up here to my reaction data. There's my experimental rate from experiment 1, 7.2 times 10 minus 6. I'm looking at the mole ratio now. 1 ammonium reacts with 1 nitrate. It's 1 and 1. So if I know the rate of ammonium, the rate of nitrite is going to be exactly the same. It is a 1-to-1 reaction. So 7.2 times 10, there we go, minus 6 moles per liter per second. And the rate of production of water in experiment 1. So again, come back to your rate data. I'll use my 7.2 times 10 minus 6 again. And this time I'm looking at a 1-to-2 ratio. So water is being produced twice as fast, essentially. So 7.2 times 10 minus 6 multiplied by 2 gives me 1.4. times 10 minus 5. And this is moles per liter per second. Now there's several other examples you can try in the workbook, and I suggest giving those a try. And we also did these in class, or we will cover them in class if we haven't already. But it's really important to make sure you know how to write a rate law, calculate the K, determine the overall order, and then maybe perhaps do a calculation or two based on different values of concentration or rate, depending on what the question is asking. But give those a try. Have a look through the workbook. There are several examples you can work on. And of course, if you need any help, as always, just reach out and let me know. And thanks for watching. Bye.